lecture. Today we're going to learn about identifying functions and using function notation. So the identifying functions part is they're going to give you maybe some ordered pairs, or these can actually be written as ordered pairs. They'll give you some sets of numbers and they'll ask you, is this a function? Or maybe they'll give you a graph and they'll ask you if it's a function or not. So I'm going to show you how to decide whether something's a function or not a function. And then the other thing we're going to do is learn about function notation. If you haven't seen it before, we're going to go ahead and show that to you. So the first thing you need to know is that it's called, if it's not a function, it's called, well actually whether it's a function or not, a relation is a pairing of input and output values. So there's always a domain and a range. The domain is always the input and the range is the output. Usually the domain is going to be X and the range is going to be Y. So I made like a little chart just to make it kind of boil it down for you. Domain is X, range is Y. If I give you an ordered pair, 5, 2, and I said, what is the domain of this point? You're going to say the 5 is the domain, and then the range is going to be the 2, because that's domain is the X's, and those are, we call those, let me show you right here. They call the X's the independent variable. It's the one that you plug in, and then Y is the dependent variable. And that might make sense because, you know, when you have a I don't know, something like Y equals 3X plus 5, the whatever Y is depends on what number you plug in for X. So Y is dependent upon what you plug in for X. Okay, so X is independent variable and Y is the dependent variable. Just giving you some vocabulary. So how do I know whether one of these relations is a function? Well, a function, well, we'll just read the long definition, and then I'll kind of shorten that up for you. It says a function is a mapping between two sets that associates with each element of the first set, the domain, a unique, which means one and only one, element of the second set, which is the range. So in other words, just to break that down, if it's a function, every X has a unique Y. So I can't have something like that. I can't have 3, 5 and 3, 1. That, because this is the X and this is the Y, right? When I plug in 3, I have to only have a unique Y that goes with the 3. There can't be, see how like two different Y's are going with my X. That's not being unique. Okay. Somebody told, I think this was in my book I taught out of last year. They said a function's kind of like a soda machine, and they would draw they'd show a little picture of a soda machine, and the buttons are the X's. Like, you know how when you walk up to a soda machine, and then there's a hole, right, and somehow your soda comes out down here somewhere. Maybe your soda machine might have Coca-Cola. Maybe there's 2 buttons for Coca-Cola because it runs out if they only put 1 button. And maybe there's orange drink and water. Okay, so the input are the buttons and the output is what comes out of the machine when you push the button. So you can have more than one X. You can have, when I push this top button, a Coke's going to come out, right? When I push this second button, also a Coke will also come out when I push that one. And that's okay. That's okay. We won't say the machine's broken. There's just 2 Coke buttons. It's okay. But if I push the Coke button and an orange comes out, and then you go and push the Coke button and a Coke comes out, That's like having two different outputs for the same input, if that makes any sense. That's what we don't want. It's not a function if you have two different outputs for the same input. Okay, so sometimes they'll show you a little picture like, let's see if we can just look at one in your book. Like this. These are the inputs. So when I put a -5 in, a 4 comes out. I don't see any more -5, so I can't really tell. This looks like a function to me because I don't have like two different outputs for any of the input. Each input, these are the inputs over here, has its own unique output. Now, oh, and this, actually, these are the exact same numbers, aren't they? So there's different ways. You could show these as ordered pairs. You could show them in a table. You can show them with these bubbles. So let's look at this one. The input is always, if they're showing them in the bubbles, the input is always on the left and the output's on the right. Is it okay that when I push the 4 button, a 3 comes out? And when I push a 3 button, a 3 comes out? That's okay. Yes, it is okay. It's still a function. Okay, and the domain is 4 and 3, because the domain is always this input, the first bubble, the left-hand bubble, and the range is the second bubble. What about this one? I push 7 and I get a 3. I push 5 and I get a 3. That's okay, but when I push 5 and get a 4, that's no good, because my input, my X's, have to only go to one output, one unique output. It looks like I pushed a 5 and got a 3 out, and then I pushed a 5 and got a 4 out, and that makes it not a function. And then if you have to list the domain and range, you just list the X's for the domain and list the Y's for the range. Okay, so I have to go a little bit faster, or else I'll run out of my time. So these are actually graphs, and telling whether something is a function when you have the graph is really, really easy. Basically, if you can draw a line, a vertical line, and it only hits the graph in one spot, then it's a function. And I'll tell you why that is. Look at this one. This is not a function because when I put in, let's see, this is 1, 2, 3. Do you see these X's? That's a 2 right there. When I put in a 2, I get out a, see the Y is a 2? That's 2 comma 2, isn't it? And then this down here, this is 2 comma, well, it's close enough. We'll say it's 2 comma -2. See how the 2, when X is 2, I have 2 different Y's? That makes it not a function. So, and also see how I can draw a line and my line hits the graph twice. It hits it twice everywhere inside the circle. So that's the vertical line test. So if I want to see if this one's a function, I draw a vertical line anywhere on the graph, and I see if I can hit the graph more than once. I hit the graph 1, 2, 3 times, so that's not a function. This one is a function because no matter where I draw a vertical line, it only hits the graph once. Okay, this is function notation. If you've ever seen someone, or in some of your math books, where it says f of x equals x plus 2, or g of x, they like using the letters f and g for function notation. So basically what it is it's a way so that you don't get, like if you have a lot of functions, you have y equals x plus 2 and y equals minus 5, and I'm even going to do another one. Here's 3 functions, and if I want to like add them up or something, or if I just want to tell you, hey, I want you to try plugging a 0 into the middle function, well then you can look and see that's the middle function. But if there were a ton of functions all over my paper, I might want to give them names. Like I can just call this guy f, and I can call this guy, we like to use f and g and h. This can be g of x, and this can be h of x. Now I can tell you, hey, why don't you find, if I want you to plug 0 into the middle function, I can say, hey, why don't you find g of 0? What that means is I want you to plug 0 into the g function. So in other words, I want you to put a 0 in where the x's are. So if I asked you to find g of 0, you'd look at all the functions and you'd go, aha, that's the g function. And then you'd plug in a 0 everywhere where you see x. Now, g of 0 is its name. It's kind of the function's label, so don't get rid of that. That's not g times 0 equals 0. That's just the name of the function. But right here you can go 0 minus 5, that's negative 5. Okay, I've run out of time, so hopefully that was enough to get you going in your homework.